Okay, hello again, guys, with this third recording of the process of solving problems and sending the solution over YouTube. This is a question was sent by Ali. The question is suggesting to use algebra to show that the recurring decimal that you see in front of you, the 0.254, could be translated into 14 over 55. So the question is asking you to convert this to prove that this could be equal to this. When you're dealing with recurring decimals, actually you're trying to translate this recurring decimal, which is this recurring decimal. When you see it in this form, I can explain a simple thing. The dot that you see on top of them, it means that they are never-ending repeating decimal. Okay, it means that they're gonna keep repeating over and over, the 5 and the 4. So you're gonna use this fact to help you out to figure out how to change this reoccurring into a form of x over y. To be able to use that, you have to understand one thing. You have to do some math, or do math that change decimal that you have into an integer. This is the basic trick. You have to change the decimal into integer. And to do that, you have first of all to assume or say that the reoccurring decimal that you have is equal to x or y, whatever it is. And you're doing this for the sake of trying to trick the math, use the trick of the math to result some sort of a fraction. Basically, you need to get rid of the decimals. And when you're dealing with this, you have to use the factors of 10. Okay, so if I say that this is x, next you have to try what is the equivalent of 10x. When I say 10x, it means that my decimal is gonna retreat to the right side by one step. So it's gonna be not 0.2 anymore, it's gonna be 2 point what? 4, actually 5, sorry, 4. And don't forget, you have an endless repeating, remember, you have an endless repeating decimal. This is the 10x. Until this point, when I look at these two decimals, it doesn't mean that it doesn't look like that they can help me to find out a way to turn it into an integer. So I'm gonna continue to find and look for multiples of 10. I'm gonna try to find the 100x. 100x, it means that I'm gonna move again one decimal step back. So it's gonna be 25 point what? 4, 5, 4, 5. Okay, this is the 100x. And when I try to look at these decimals, it might work out, but I'm trying to teach you how you can do it smoothly, how you can discover an easy integer after doing a set of calculation. Let's try to find the 1000x. 1000x, it means that I'm dealing with 2, 5, and then I'm gonna step back one more decimal, and then I'm gonna add my decimal here. Now I need to look and to compare the digit that you see in front of you of this one and this one. It seems that if I try to subtract these two values, they can help me out figure out an integer value, if you understand what I'm talking about. Because if I said that, I'm gonna erase this theory part here so I can continue solving this. So if I decided to say that 1000x minus 10x is gonna result in what? It's gonna result in 254.5454 minus 2.5454. And when I'm looking at the left side, I'm gonna translate it into what? 1000 minus 10. You're gonna do normal subtracting now. So it's gonna be equal to 990x. Okay, equal to what? When you do the subtracting, this decimal is gonna delete this decimal, and actually you're subtracting what? 254 minus 2, which is gonna be equal to 252. Now the idea is to make the x as the subject, as you can see. X now is gonna be equal to what? 205.20 over 990. Now you try to simplify this fraction to reach the 14 over 55 by using 2 as a common factor or 3, whatever it is. And since you have even here, even values, you can try to start with the 2. If you try to change it into 2, this is going to be equal to what? The 252. The first value, when you try to divide it over 2, is going to result in 126. And the 990 is going to be actually equal to 495. And you're going to continue to simplify until you prove this. This is the trick. Here we have 6 at the numerator, and the denominator have 5. So it seems like that you have to try to divide by maybe 3. If I say that I want to divide this by 3, the 12 has 4 3's and the 6 has 2. So here we have 42 since we divided in 3, and we divide on 3 here as the same. So it's going to be 1, and you have 1 with the 9 is going to be 19. 19 divided by 6 is going to be 6, and you still have 1. The 1 is going to go with the 5, so you have 15. So 15 divided by 5 is going to be 3. Actually, it's going to be, 15 divided by 5 by 3 is going to be 5. So now we have 24 over 165. You are getting closer to this, to 14 over 55. Now you look at the 42 and you have the, it seems that you can continue with the 3. So it's going to have 1, and you still have 1 with 12. The 12 has 4, so it's going to be 14. And here you're going to divide by 3. The 16 has 5 3's, and you still will have 1. 1 with the 5 is going to be 15. So it seems like 55. And as you can see, we proved that the 0.254 is actually equal to this fraction. That's it for this video. So that was proved. See you in the next video, inshallah.